Hey guys, so we're moving on to the last set of notes for Unit 1, and that is on the distributed property and combining like terms. So the distributed property, as highlighted up here, is when you have a set of parentheses with a number on the outside. So if you have something that looks like this, you have a 2 on the outside that you have to multiply in to the x and into the 4. So when you do so, you make sure you distribute what's called distributing the 2 throughout the parentheses. So you multiply the 2 times the x, so you get 2x as your final answer there, and then you multiply the 2 times the 4 so that you get a final answer of 8. And then when we write our answer is an expression, so our answer is 2x plus 8. Another important thing to remember when you're doing the distributive property is your integer rules when it comes to multiplying and dividing. So when you are multiplying or dividing with integers, remember if they have the same sign, then your answer is positive. If they have different signs, then your answer is negative. Okay? So remember that when you're dealing with the integers, okay? The ones that have negative and positive signs. So let's look at our first example. In our first example, we have 3 on the outside, parentheses, c plus 5. And we're going to distribute that 3 into the set of parentheses. So we're going to take this 3 and multiply it into both pieces. So this becomes 3, and I'm going to use parentheses to indicate multiplication, times c plus 3 times 5. 3 times c, we can just write as 3c. It simplifies to 3c. And then 3 times 5 is 15. And this is our final answer, 3c plus 15. Remember, we are still, in fact, following PEMDAS here, or the order of operations, because we're doing the multiplying first, and then we're putting them together. Okay, so let's try the next one. In the next one, we have 4 on the outside and 2 minus x on the inside. So when we rewrite this, we're going to say 4 times 2 minus 4 times x, okay? I'm distributing it into both pieces. So 4 times 2 is 8 minus 4 times x, we just write as 4x. And there's our final answer, 8 minus 4x. Let's look at the next one. Sometimes they will give it to us in sets of 3 different terms. So when you have something like this, remember you're going to take this negative 4 on the outside and you're going to multiply it into all 3 terms. So 1, 2, 3. So I'm going to have 3 sets of multiplication going on. So first, if I write this out, I have negative 4, and I'm going to use parentheses, times 2u. And then I have a minus, and I'm going to use parentheses here, negative 4 times 5y plus negative 4 times 3. And all I did was I kept the signs that were inside, and then I just distributed that negative 4 in, and I put parentheses around it to indicate that I want to multiply. So now I'm going to do the multiplying, and this is kind of hard to look at, so let's highlight what it is that we're going to be multiplying and simplifying here. We've got the first one, and then the second one, and then we have this last one that I'm going to do for multiplying. So if I break those up, I have negative 4 times 2u is negative 8u. And then I have minus negative 4 times 5y is negative 20y. And then I have negative 4 times 3, so I have a plus, negative 12. And the reason I put these parentheses around is because they have different signs, so I have to make sure I adjust those signs accordingly. Double negative here, remember, a double negative here becomes a positive, and plus a minus, there is no such thing. Instead, you just call this a minus. So when I write my final answer, I'm going to say negative 8u plus 20y minus 12. And that's my final answer. Okay, so it needs to be simplified as much as possible. Let's try the other example to show you a little bit more. Remember that we're dealing with integers here, so it takes a little bit more practice, okay? When you're multiplying and they have the same sign, you get a positive result. And when they have when they have different signs, then you get a negative result. So remember, we're multiplying this -7 into all three pieces. So we're just going to write it out first. We have -7 times -x plus -7 times 3b minus -7 times 4. Okay, and look how I split that up again. We're doing 1, 2, 3 multiplying situations here. Okay, so we're going to solve each of these. So we've got -7 times a -1x. Technically, there was a 1 out front of that x. So -7 times -1 is positive 7x. Okay, plus -7 times 3 is -21, and we're just going to carry the b with it. Okay, minus -7 times 4 is -28. 7 times 4 is 28, and the sign is negative. Now we're going to simplify the signs. Remember, we still have the 7x plus a negative becomes minus 21b, and the double negative becomes plus 28. And there's our final answer there. Okay, so make sure you take your time with these distributive property examples, because the longer that they get, the more terms that you have to multiply in, then the trickier they get. Okay, and make sure you're paying attention to those signs. Now moving on to combining like terms. When you are combining like terms, it's important to know what like terms actually are. So like terms are terms that contain the same variable. So x, y, z, whatever the variable may be. Okay, it's the letter raised to the same power, which means that the variable has to, if one of the variables is x squared, then if one of the variables is x squared, then the like term to x squared also has to have an x squared. So you can have x squared and 2x squared, and those are considered like terms because they both have the x raised to the second power. So the same variable raised to the same power. So look at your examples that they give you here. They say 2x is the same as 5x, or is a like term with 5x, 4x squared, 7x squared, those are like terms, and 6xy squared, sometimes they'll combine 2 and 1, and -8xy squared are like terms because they both contain an x and they both contain a y to the second power. And then it says that you can add and subtract like terms, so you can always add and subtract like terms. So let's look at our examples. 3c plus 5c. Notice that those are in fact like terms because they both contain the letter c. They both have the same variable raised to the same power. So we're just going to simplify this. 5 plus 3 is 8, so our final answer is 8c. And we carry along the variable. Look at our next example. 8b and 2b are like terms because they both have the same variable, so we can subtract. 8 minus 2 is 6b. In the next one, we have like terms, 2x and x, same variable raised to the same power. So 2x plus 1x, there was always an imaginary 1 out front of a variable, is 3x. In the next one, we have -4a and 7a. Those are like terms, so we can combine them. And if I use my integer rules, remember -4 plus 7, you subtract and keep the sign of the bigger number. So 7 minus 4 is 3a, and keep the sign of the bigger number. The biggest number is 7, and it's positive. So that's our final answer there. In the next one, we have like terms, 8a and 5a. Those are like terms. So -8 minus 5, they have the same sign. So you add and keep the sign. So 8 plus 5 is 13a, and you keep the sign. Of both of those, which is negative. So my final answer would be -13a. And then in the last one, those are again like terms because you have the same variable raised to the same power. And we're going to use integer rules again. Those are different signs, so you're going to subtract and keep the sign of the bigger number. 12 minus 2 is 10, And the sign of the bigger number, 12, is negative. So our answer must be negative 10a. So don't forget to carry along the variable along with it, and then you can just add and subtract like terms if you find that they are alike. So you have the practice on Alex, the 1.4 practice on Alex to try, and let me know if you have any questions. Good luck.